Let's say you're the head of a bank, hospital, or high-tech company. Privacy is of the utmost importance to you, but you've also been hearing about the insane productivity gains that AI offers. The big AI labs say that they won't train on your data, but even letting it leave your network feels risky, and rightfully so. So what to do? Don't AI models cost tens of thousands of dollars of computer hardware to host? And isn't it hard? That's exactly the problem one of our clients, a CTO of a high-tech cloud computing company, had. His company is built off of intellectual property, code that he cannot afford leaking out under any circumstances. But imminent delivery deadlines made him take a good hard look at AI's huge productivity gains for coding. At first, he was looking for an enterprise-grade solution to do the bulk of his coding all at once. But all of these kinds of solutions required the code to go online, which he couldn't risk doing. So we proposed a different approach. What if we used locally hosted AI to make your developers more efficient using an AI coding tool, all while offline for a couple $1,000s? And that's exactly what we did. We used less than $3,000 worth of used hardware, free open sourced AI models, and a free AI coding tool to achieve 30% productivity gains for a developer team of 4 over 1 month. First, I'm going to go over how things work at a high level from a network perspective. In general, we're dealing with an air-gapped private local network, which means it's a local network that's not connected to the internet. Why is it not connected to the internet? Because, again, this is a high-tech company where all their value comes from their intellectual property, their code. If they expose it to the internet, it might leak, and that's something that they don't want ever. So that's why it's air-gapped. And because it's air-gapped, it's not connected to the internet, and so they can't access online AI models like, ChatGPT or anything from OpenAI or Anthropic through online APIs. So how their local network works is that they have a bunch of servers, like one of these development servers, that is split up into a bunch of virtual machines or virtual computers that act as the developers' coding devices. And so what we did is that we introduced this AI server here in purple, and we first connected it to the internet to download AI models. We split it up into 2 AI server instances, one for larger models and one for smaller models, just so they wouldn't interfere with each other. And after that, we cut off the AI server from the internet for security and then connected it to the local network so that the developer machines can access the AI models through the local network. So here's how we set up the AI server. We first set it up with its hardware. So we gave it 128 gigabytes of RAM and 88 gigabytes of VRAM. This is sufficient enough to run GPT OSS 120B, which is the biggest open source model from OpenAI with 120 billion parameters. The company, being a cloud computing company, they set up their own proprietary secure OS as the hypervisor, which lets you divide the server into 2 virtual machines, as we discussed. And then on these 2 virtual machines, each we installed Ubuntu 22, which is a Linux operating system. It has a UI, it makes things easy to customize. And on top of that, we installed Ollama. Ollama is an LLM management tool, which allows us to download the models as well as have the models work with the hardware that we have here. And we downloaded different models for chat, like GPT OSS 120B, smaller models for edit and apply functions, and we'll get into that later. And then on the development machines, we downloaded VS Code, which is a coding environment or IDE. We downloaded continue.dev as an extension on top of that. And then we surfaced all of these models from Ollama through a port on the AI server to the local network. And then using that port, we were able to connect continue.dev, which is a coding extension that basically mimics the functionality of Cursor, which is, as you know, probably the most popular AI coding tool. And it's able to use the AI models from the AI server. I also wrote a pretty thorough guide on Medium explaining exactly what we did. This is what it looks like. So we have the diagrams that I showed you already. This is the hardware. So nothing fancy, but 4 GPUs, 88 gigs of VRAM, CPUs are under here. I go through the general setup, the operating system that we chose, again, Ubuntu, which is a Linux environment setup, basically installing NVIDIA drivers, CUDA, which is for NVIDIA as well, downloading Ollama here, doing system configuration for Ollama to make everything work properly, port configuration, which basically lets Ollama talk to all of the other devices on the network using this port. And then I go through model setups. Basically, in the continue settings for VS Code, you have a lot of models that you can set for different things, right? So here on the left side, I'll show you. You have models for chat, autocomplete, edit, and apply. We're using GPT OSS for chat, QN Coder 30B for apply and edit, and we're using QN 2.5 Coder 7B for autocomplete, and they're all required for continue to work properly. So I go over how to select for models here, exactly what the roles do as well. I go over how to download models, which models we used. I also go over VS Code and continue IDE setup, which is where the vast majority of the troubleshooting took place. Some settings here, adding the models like I showed you here. I go through examples of model setup and continue here, as well as setting models for the agent. This is what it looks like when it's done. Very cool. And then I also go through a lot of troubleshooting steps. And we hit a lot of issues when we were building this, so in case you do, we guide you through them. And basically, this is the technical result for what we did. We set up the server hardware and installed the Linux OS onto it, configured the server and Ollama to surface AI models into the local network, then used VS Code as the coding IDE and set up the continue extension on the development devices, and then we configured the settings to have the models work correctly. And basically what this all resulted in is an offline, private, local network AI-assisted coding environment that contributed massively to the productivity of this company's development team. We also set up a local AI chat using anything LLM for coding-related chat stuff. So again, local AI network, AI applications don't just stop at coding. This is one of the more complicated, open-ended things you can do with local AI, but any AI solution that you might need that handles data that you don't want exposed to the internet at all costs starts with the things that we discussed today. So if you value security and data privacy for your organization, but don't want to miss out on the incredible gains that the AI revolution can bring for your business, contact us, and I'll see you next time.